Well, now let's take a look at how we can actually use this multiplication law for independent events to calculate some unknown probabilities. Before we jump into that though, take a look at the box that we have here at the top. What we can see is that we can actually generalize a bit more this idea of how we compute the probability for independent events when I'm interested in one event and another. Now what you'll see here is I again have these little hump symbols in here. Remember that those stand for the word and, but they start to become very, very useful to use when I begin to have a lot of events all listed together. Let's see what this says. If events A1, A2, A3, all the way up to AN, so like I could have pretty much any number of events, but if they're all independent of each other, then if I wanted to know what's the probability that this thing happens and the next thing happens and the next thing happens and the next thing happens all the way down the line, I can kind of expand my rule to just say, take the probability of each individual piece. So notice that this is extremely similar to what the blue formula states. It here just had two events, and so we said multiply the two probabilities for each together. But this law down here says, well, you can generalize this to now work with any number of events. So if you had A1, A2, and A3, you would just multiply probability for A1, A2, and A3 together. And if you had all the way up through A100, you'd multiply all 100 probabilities together. Okay, this is kind of nice. Let's see how this works here on example number 3. A major oil company has decided to drill, very important buzzword here, independent test wells in the Alaskan wilderness. The probability that any well produces oil is 0.3, so 30%. Find the probability that the fifth well is the first one to produce oil. I'm going to come up here with just a couple quick little symbols to help with this. I'm going to have S stand for successfully find oil, and I'm going to have the symbol F here stand for fail to find oil, just so I can easily talk about what I'm actually looking for in this question. I can see right now that the probability that I find oil, that is the probability of S, is given to me already as 30%. So of course then the probability of not finding oil should be, well, 70%. Okay, so let's think about what it is that we want to find. We want to find the chances that the fifth well is the first one to produce oil. So again, think about this like it's an actual real-life context. Try to imagine the story. Okay, so the company is going to go ahead, they're going to start drilling their first test well in the Alaskan wilderness. Do we want it to find oil? Well, if we want to try to find the probability that the fifth well is the first one to produce oil, then no, we would want failure on the first attempt. And then, and I'll use this shorthand symbol here, we would like to go ahead and start drilling the second test well. Strike oil or not strike oil? Well, we probably want an F again. We want to fail to find oil. We want the fifth well to be the first to find oil. So notice that means I'm going to need to have 4 failures in a row and then an S for a success of finding oil. This is what I'm looking for. I want a failure, and then a failure, and then a failure, and then a failure, and then a success. But since I know that these are independent, and gosh is that important, I know that since they're independent, I can actually say these two things will be equal. So I can instead change this to probability of F times probability of F times probability of F times probability of F times probability of S. Now, if you're a big fan of exponents, you could rewrite this as probability of F kind of all to the 4th power, right? Because it's multiplied 4 times in a row, and then have the probability of S. I don't really care which one you do, but sometimes using that exponent notation is a little bit shorter. So notice here what I'm really going to have is 0.7 to the 4th power, or 0.7 times itself 4 times in a row, and then times a 0.30. If you went to a calculator, you typed this in, crunched it out, you'd end up with something like 0.0720. Okay, so like this might actually be some information that a company might actually be interested in knowing, right? Like what are the chances that we might actually fail 4 times in a row before succeeding? All right, I mean, maybe that's going to, dictate how much money they need to invest before They actually start just drilling randomly. So information like this, understanding these sorts of probabilities, can be a very, very useful tool. In the next example, we'll see how we can kind of put all of this together to answer a whole bunch of different questions related to a news scenario.